Alright, welcome to episode 3. What we did in the past 2 episodes is basically just having a small prototype of the interpreter. And today we're gonna start with the parser. For that I'm gonna make use of the num library. I'm not completely sure if I will stay with that, but it does seem to be a good place to start and might serve for the long term also. So we're gonna have to put in our dependencies and then start using it. Right, let's see, what do we need? We need the character parsers from the complete version of num. And we're gonna need some combinators. All right. Let's have a small parser function which will pass a symbol. Okay, let's see if that works. Yeah, I guess it's not combinators, it's just combinator. Let me just try something. I mean, obviously I'm cheating again and retyping stuff I've used somewhere else. And no, that's not it. Let me see, how did I do it before? Alright, yeah, no, it's I have to actually called the parse method, I think. Let's see. Yes. It doesn't work like I expected. Why? This is surprising. Yes. It might, yeah, like, this one should work. Yes. So basically, if all other characters in the symbol are alphabetically, then it just, this one takes care of it and this one doesn't find anything anymore. But yeah, I was thinking, okay, this just does the first one and everything does the rest, but that's not actually how it works. So I have to wrap this so that it is fine if it doesn't find anything. And this one is from multi many zero. I think many zero would just without the count would also work, but I think this count thing is a bit faster, which is like, I mean, it's not the stage really to worry about performance, but somehow it like feels wrong to use the slow version when the fast version really is just 5-6 more characters. Yay, it works. Then we want to also be able to parse some numbers. Which for now we're just gonna do digit 1 parse. Let's see. Because I need to actually import it. This works too. Nice. Let's see, what did you want to parse? Something like this. So we will also have to parse like operations or instructions. I think, yeah, we'll call them instruction. Here this time we're gonna actually not just return like a span of the original string, but actually one of our own data structures. So we want delimited. Something like, yeah. Is it actually, I think in Rust it's like this. See, does it work? We need to import it. Alright, yeah. Just says me that I ordered wrong. And then of course we need to have the char function. We have to fix it here too. Right, and now we actually need to make an instruction out of a diff. Let me see how does this map. Just a normal normal lambda. Yeah, we're gonna need some more stuff here. Let's just do another vector. Alright, so so we now should be able to pass if instructions, but of course it won't work like that because you would have to have like an infinitely nested code of ifs, because at the moment we can only pass if instructions. So let's maybe be able to do some literals. Okay. Let's see. Alright, then we do need a function which I also want to call pinst, which combines those two passing functions, which means I have to rename this maybe call this praise inst. Alright, and for this we need an alternative, because we either gonna pass literal or raised instruction. Which means I do gonna have to import it, and I think it's in combinator. And then we're gonna have to define this. Subtle sounds Mexican. So let's see what nice nice function we could have here. Let's see, I think just a many 0 preceded. Yeah, but I always have to actually call the parser. It's a bit annoying. But I haven't yet actually figured out how to get rid of that, or if that's even the intended design to have it more more compact like this, or if it's just how this library works, that you always have to be very explicit. Okay. So here we actually need a mini 0, and we're gonna have to have our multi-space 0. So let's see. And yep, we need some more. This map is in a combinator. And actually alt is in branch. And then yeah, we actually need to have some specific variant here. Are we gonna pretend that this will always succeed? Which actually, yeah, the parser does its job. Actually should. Unless there's some overflow condition. Right, so I might actually have to handle that at some point. And I need to import preceded. which is also in sequence. Okay. Yes, I'm somewhere not calling parse. Okay, some trill error. Right, yeah, I have to actually, yeah. Can't do it in line. I think that's what the compiler is telling me to do. Yeah, I'm too used to parser combinators in like Clojure or Haskell, where you definitely don't have to like do this kind of stuff to like remember to always do it. Let's see what I'm doing wrong here. There's something, this map thing, look at some other code. It doesn't actually need the, it's called as a function, not as a parser. But that doesn't actually. Wait, yes. Wow. Yeah. Let's see. So I actually do have to. Okay, we are at the point of the board checker, which is always good because it means everything else type checks. Let's do the easy way. For now at least. I mean, it should actually not be necessary to have like to clone all these instructions because I'm not gonna use them somewhere else. No idea if it complains because it doesn't recognize foo. So at some point, because basically the syntax for macros gonna be like the same, like for an if or something, I will have to be able to pass like arbitrary operands here. But for now, let's just test this. Nice, it works. And yeah, this is like half an hour about. So I will stop the episode here, and next episode we're gonna try to actually execute some code via parsing. See you then.